Welcome back to Quantitative Reasoning. During our previous 3 tutorials, we worked with a subset of the 2017-2018 NHANES dataset for body measurements. There's one set of measurements for each woman aged between 20 and 25 years who participated in the survey. You can find the data at the URL below this video. Last time, we looked at the residual plot for the linear model of upper arm length as a function of body height. Here are the commands to reproduce the residual plot. The x-coordinates are fitted values, that is, the upper arm length that is predicted on the basis of a participant's body height. In the scatter plot of the observed upper arm length versus the body height, the fitted upper arm length is the y-value of the regression line for a given body height. For example, this plot shows the fitted upper arm length of the blue data point. For the purpose of making the residual plot, R automatically calculated the fitted values for us, but sometimes we would like to determine predicted values ourselves. In principle, we can determine the predicted values from the y-intercept and the slope of the regression line, but R offers a more convenient way for this task, the function predict. The first argument in predict is the fitted linear model, usually calculated with the function lm. In our script, we gave the fitted linear model the variable name model. If model is the only argument passed to predict, the return value is a vector that contains the fitted y values for the observed x values in the dataset, which is in our case the data frame BM. For example, the linear model predicts an upper arm length of 35.09 centimeters for the participant in row 1 of BM. This prediction is based on her body height, which is 158.4 centimeters. Her true upper arm length is 36 centimeters, close to the predicted value of 35.09 centimeters. Calculating the fitted y values of the participants in the study can be useful, but it's even more interesting to predict upper arm lengths for women who weren't part of the sample. Suppose we know the body height of a woman in the same age group as the study participants, but we don't know her upper arm length. What is our prediction? Suppose we want to make predictions for 3 women with body heights of 155.2 centimeters, 158.9 centimeters, and 165.1 centimeters. Let's fill these values into an object called measurements. The predict function expects these predictions to be in a column of a data frame. The column name must match the name of the variable that we used as a predictor when we built the linear model with lm. In our example, we used the formula upper arm length tilde height, so the column in the data frame must be called height. We can pass measurements as a second argument to predict. The name of this argument is new data. The result shows that the linear model predicts an upper arm length of 34.36 centimeters for the first woman in the data frame measurements, 35.21 centimeters for the second woman, and 36.63 centimeters for the third. Of course, we would have obtained the same values if we had inserted the body heights into the equation for the regression line, minus 1.1579 plus 0.2289 times height. However, using the predict function makes the intention of our calculation more obvious to somebody else who reads our R script. It may feel awkward that we must put the 3 measurements into a data frame. Why doesn't R allow us to pass a simple vector as new data argument? The answer is that the function predict is designed to handle general statistical models that may rely on multiple predictor variables. For example, we may want to build a model that predicts upper arm length on the basis of arm circumference as well as body height. For a model with multiple predictor variables, it makes sense to enter different variables as different columns of a data frame. For our model, which only has body height as a single predictor, this approach may feel indirect, but in the end, we get the information we are looking for. In summary, we use the predict function to obtain predictions on the basis of a linear model. The first argument of predict is a concrete linear model, usually calculated with lm before we run predict. If the linear model is the only argument passed to predict, R returns the fitted values for the observations that we passed as arguments to lm. If we want to get predictions for a new set of observations, we must create a data frame in which R can find the predictor variable as a column name. Then we pass this data frame as a second argument called new data to the predict function. Predictions are, of course, generally different from the truth. In reality, we usually encounter a certain degree of randomness. Next time, we learn how we can use R to generate random samples from a finite set of objects. See you soon.